Good everyone, you are welcome to your favorite learning channel. My name is Oluwatoyin. In today's topic, I'm going to discuss about the chemical properties of aromatic hydrocarbons, the chemical properties of aromatic hydrocarbons and the physical properties of aromatic hydrocarbons. Under the chemical properties of aromatic hydrocarbons, I'm not just going to give you the chemical products, I'm going to explain the formation of your chemical products under chemical properties of aromatic hydrocarbon. In my last video, I've explained the IUPAC nomenclature of aromatic hydrocarbons and the method of preparation of aromatic hydrocarbon. So let's first look at the physical properties of aromatic hydrocarbons. Number one, they are highly inflammable. They are highly inflammable. Inflammable, that is, inflammable means something that can easily burn. Something that can easily burn, or something that can be easily set on fire. Something that can be easily set on fire. So another one, it boils at 80 degrees Celsius. It boils at 80 degrees Celsius. It boils at 80 degrees Celsius. Then number three, they are non-polar solvents. It is a non-polar solvent. So it is a non-polar solvent, therefore it is immiscible with water. It is immiscible with water. Then another one, it is a non-electrolyte. It is a non-electrolyte. It is a non-electrolyte. Therefore, it does not conduct what? Electricity. Since it is a non-electrolyte, it does not conduct electricity. Number five, its vapor is carcinogenic. Its vapor is carcinogenic. That is, its vapor can cause what? It can cause cancer when inhaled. It can cause cancer when inhaled. Then it is a colorless liquid. Number six, it is a colorless liquid. It is a colorless liquid. It is a colorless liquid with unpleasant and toxic odor. It is a colorless liquid with unpleasant and toxic odor. So it is a colorless liquid with unpleasant and toxic odor. Then the last one, it induces headache when inhaled. It induces headache when inhaled. When inhaled. So those are the physical properties of aromatic hydrocarbons. Physical properties of aromatic hydrocarbons. So let's move to the chemical properties of aromatic hydrocarbons. So let's talk about the chemical properties of benzene. chemical properties of benzene. So the first one is combustion reaction. Combustion reaction. Combustion reaction. That is, what is the word combustion? Combustion means burning of substance in air or oxygen. Combustion means burning of substance in air or oxygen. Then whenever any organic compound reacts with air or oxygen, it will give us carbon 4 oxide and water. It will give us carbon 4 oxide and water. So combustion is what? Is common to all organic compound. Combustion reaction is common to all organic compound. And whenever any organic compound reacts with air or oxygen, your products will be carbon 4 oxide and water. So benzene burns in air or oxygen to produce hot, smoky flame. Benzene burns in air or oxygen to produce hot, smoky flame due to higher carbon content in its molecule. Due to higher carbon content in its molecule. So let's see chemical reaction between benzene and oxygen. Then now we're going to form our product. Carbon will react with oxygen to give you carbon 4 oxide. Then hydrogen combine with oxygen to give you H2O. So our product is carbon 4 oxide and steam. Carbon 4 oxide and steam. So that is the first chemical reaction. Then the second chemical reaction is substitution reaction. The second chemical reaction is substitution reaction. Substitution. And what's the word substitution? To substitute means to remove something and replace with another thing. You remove something and replace with another thing. So under this substitution reaction, one or more hydrogen atom will be removed from the molecular formula of benzene and will be replaced with something else. One or more hydrogen atom will be removed from the molecular formula of benzene, then you replace it with an atom or a group of atoms. Now, this substitution reaction will take place in the presence of an inorganic catalyst. The substitution reaction will take place in the presence of an inorganic catalyst. And the major organic catalysts that we always use for this chemical reaction are aluminium chloride and iron 3 chloride. So our catalyst e.g. is either you use aluminium chloride or iron 3 chloride. So aluminium chloride and iron 3 chloride are inorganic catalysts. Then we know the function of catalyst. Catalyst will speed up the rate of chemical reaction. Now, let's take the first chemical reaction under this substitution reaction because we have sub-chemical reaction under substitution reaction. The first one is alkylation. And what is the meaning of alkylation? Means addition of an alkyl group to benzene structure. Addition of an alkyl group to benzene structure. So benzene will react with an alloalkane. So the alkyl group from that alloalkane will be added to the structure of what? Of benzene. And one hydrogen atom from the structure of benzene will be displaced. I'm going to use both molecular formula and structural formula to explain this chemical reaction. So don't forget that under alkylation, we need what? Alloalkane. So there will be addition of alloalkane. That is halogen and alkane to the structure. But from this alloalkane, you add an alkyl group from alloalkane to your benzene. That is why they call it alkylation. Alkyl, that is addition of alkyl group to benzene structure. So let's first use molecular formula. Benzene is H6, then plus aloe and alkane, that is halogen and alkane. You remove one hydrogen atom. CH3 is an alkyl group, which is called methyl. Let me write examples of alkyl group. We have methyl, we have ethyl, we have propyl, we have butyl, we have pentyl, and so on and so forth. So the molecular formula for methyl is CH3. That of ethyl is C2H5. Propyl is C3H7. Butyl is C4H9. So let's continue. So when you take methyl and you add an halogen to it, it will give you aloalkane. So methyl CH3. Then halogen, you can use chlorine, you can use bromine, you can use fluorine, then you can use what? Iodine. So you can use any of these halogens. These are halogens. So let me use chlorine first. So this is chloromethane. Chloromethane, because CH3 is from methane. CH3 is from methane. Now, how are we going to form our products? From this C6H6, we release one hydrogen atom. If we release one hydrogen atom, so we are going to have C6H5. There will be release of one hydrogen atom. So this is the hydrogen atom. So this one, the chloromethane, will now decompose to CH3. CH3 is an alkyl group, that is methyl, and chlorine, that is halogen. So this hydrogen is positive, it carries positive ion, then positive charge. Then C6H6 automatically will carry negative. Then this is positive, then chlorine is what? Negative. Then according to our method of balancing of chemical equation and formation of products, a positive will react with negative to give you a compound. Positive ion will react with negative ion to give you a compound. So therefore, you take this positive and react with this negative. So C6H5 will combine with C6H3. So the positive will cancel the negative. So to give us C6H5CH3. C6H5CH3. So this CH3 is an alkyl group. So addition of alkyl group to benzene structure give alkylation. So plus, then the hydrogen here, which is positive, will combine with this negative. So positive will cancel negative, then the two will come together to give you HCl. So our product is now CH3 is methyl. CH3 is methyl, and this one is from the structure of benzene. So you call it methylbenzene. Methylbenzene. So our product is methylbenzene and hydrogen chloride. So it's not only methyl that you can use. So you can also use ethyl. So that would be ethane and what? And chlorine. So let's take one more example before we proceed. Your benzene C6H6 plus, then I will use the second member of alkane. C2, it should be C2H6, but there will be loss of one hydrogen atom for halogen to come in. So that will be C2H5, then an halogen. Let me use another halogen. Bromine is what? Is halogen. So C2H5Br2. That will be bromoethane, because C2H5 is from what? From alkane. Bromoethane and benzene. Bromoethane and benzene. So the benzene will lose one what? We lose one hydrogen atom. So that will be C6H5, then H. Then this one will decompose to an alkyl group that present here. That's C2H5 and bromine. Bromine carry negative charge. The alkyl group positive. This is positive. Automatically, this one will be negative. So positive will combine with what? With negative to give us a compound. So our product will be C6H5C2H5 plus, then hydrogen will combine with bromine to give us HBr. Br. So now let's name our product formed here. C2H5 is ethyl, while C6H5 is from the structure of benzene. So what will you call it? You call it ethyl benzene. Ethyl benzene and hydrogen bromide. Ethyl benzene and hydrogen bromide. That is alkylation reaction. Alkylation reaction. So let's move to the next stage. Then before we move to the next stage, they can give you this chemical reaction in form of structural formula. It can be in form of structural formula. So let me explain the structural formula of this chemical reaction. Then you just all you need to do is to draw the structure of benzene. The structure of benzene. You draw the structure of benzene, either the resonance structure or the Kekulé structure. So this is the structure of benzene plus C2H5Br. Then by the time you want to bring anything here, don't forget that there is an attachment of hydrogen atom. If you use an open chain structure, there is an attachment of hydrogen atom at this side. So when you are removing when you are bringing something in, you must remove one hydrogen atom. So your product will now be in this form. So for anything to come in here, you remove one hydrogen atom. You remove one hydrogen. So the hydrogen atom will go out for what? C2H5 to come in. So you bring C2H5 here. C2H5. Then the hydrogen that you remove from this place will then combine with bromine to give you HBr. This is the structural formula, while this is the molecular formula, the chemical reaction in form of molecular formula. So it can come, your question can come in this way or in this way. So let's move to the second chemical reaction, under substitution reaction. We are still under substitution reaction. So number 2 under substitution reaction is halogenation. Halogenation. Then halogenation means addition of halogen. Halogenation. Halogenation. Halogenation means addition of halogens, e.g. bromine, chlorine, iodine, and so on and so forth. So let's start with the molecular formula form. So plus an halogen. Since we call halogenation addition of halogen to benzene structure, then halogens are diatomic molecule. They are diatomic molecule. So by the time you write any halogen member, since it is a diatomic molecule during chemical reaction, you have to put 2 at the what? 2 at the base. So it is a diatomic molecule. So reaction between halogen and bromine now will give us what? Now let's see how we are going to form our products. So by the time halogen reacts with what? With benzene. Then don't forget that the chemical reaction under substitution reaction will take place in the presence of what? Of catalyst. I beg, don't forget to add your catalyst. It will take place in the presence of what? Of a catalyst. Now this C6H6 will decompose to C6H5, then hydrogen. Then the bromine will decompose into 2 Br. Then this C6H6 will combine with 1 Br to give us C6H5Br. Then the second Br will combine with hydrogen. Hydrogen will combine with second Br to give us HBr. So what is the product form? C6H6 is from the structure of C6H5 is from the structure of benzene, then plus bromine. Then bromine will sound bromo, so we call it bromobenzene. 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 That is the name of the product form. So you can also do it in form of structural formula. You can write it in form of structural formula. So just draw the structure of benzene. Your benzene structure, then plus Br. Then for anything to attach to any of the carbon atom here, you remove hydrogen. So for anything to come in, there will be what? Removal of hydrogen, elimination of hydrogen. Then one of the bromine will come in. When one bromine come in, the second bromine will combine with hydrogen that you eliminated here to give you HBr. This is the structural formula form, while this is the molecular formula form. Then with addition of your what? Of your catalyst. Since reaction will take place in the presence of what? Of a catalyst. That is halogenation reaction. So let's move to the next one. The next chemical reaction under substitution reaction is called nitration reaction. Nitration. Nitration reaction. Then what is the meaning of nitration? Addition of triazonitrate 5 acid. 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 That is concentrated triazonitrate 5 acid. And the reaction will take place in the presence of concentrated H2SO4. That is, concentrated H2SO4 will be your catalyst. Concentrated H2SO4 will be a catalyst during this chemical reaction. So let's use structure, the molecular formula form C6H6 plus what? Triazonitrate 5 acid, which is what? HNO3. HNO3. So the benzene will decompose to C6H5 and H. There will be removal of one hydrogen atom from 6 hydrogen atom here. Then this one will decompose to NO2. NO2. When you remove NO2 from this place, it will remain OH, then an OH. So NO2 and OH. So the C6H5 will combine with NO2 to give us C6H5NO2. Then hydrogen will combine with OH to give us H2O. So in chemical reaction, whenever hydrogen ion combine with an hydroxy ion, it will give you water molecule. 1, 2 hydrogen, 1 oxygen. So this is our product. So what is the name of the product formed? NO2 is called nitro. That is nitrogen and oxygen. So you call it nitro. Then this one is from benzene structure. C6H5 is from benzene structure. So the name of this compound is called nitrobenzene. 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 Then if you want to use the structural formula method, you draw the structure of benzene. Then plus HNO3. So to the structure, you add your nitro. Then you substitute your nitro with what? The hydrogen atom with nitrogen. You remove hydrogen atom here, then NO2 will come in. So you attach your NO2, then the hydrogen will combine with hydroxy group to give us H2O. This is the structural formula form. Then don't forget that reaction will take place in the presence of concentrated H2SO4. So conc H2SO4 is your catalyst. H2SO4 is your catalyst. Concentrated H2SO4 is your catalyst during this chemical reaction. Then number 4 chemical reaction under substitution is sulfonation. 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 Number 4 is sulfonation reaction. Sulfonation reaction means addition of tetraoxosulfate 6 acid. Addition of concentrated tetraoxosulfate 6 acid, that's H2SO4. So H2SO4 will be added to benzene molecule. It will be added to benzene molecule. So benzene is C6H6 plus H2SO4. So reaction of benzene with H2SO4 will decompose benzene to C6H5, then 1 hydrogen. Then this tetraoxosulfate 6 acid will decompose to OH. Remove 1 hydrogen here, 1 oxygen here. It will remain 1 hydrogen and sulfur with what? 3 oxygen. So this is positive, this is negative, this is positive, this is negative. So positive and negative will combine together to give you a compound. So our first product will be C6H5, then HSO3 plus hydrogen will combine with hydroxy ion to give us H2O. So what is the name of the product form? Then don't forget that this one is from what? Is derived from benzene. C6H5 is derived from benzene. So our product will now be benzene hydrogen triazo. Since we are having 3 oxygen, we call it triazosulfate 6. So the name of this product is benzene hydrogen triazosulfate 6. Benzene hydrogen triazosulfate 6. So let's take the last chemical reaction under chemical properties of benzene. So the last chemical reaction is called addition reaction. So number 3 is addition reaction. Then under this addition reaction, we have some chemical reaction. Number 1 is halogenation. So which shows that benzene undergo both halogenation reaction, is undergo both addition reaction and substitution reaction. Benzene undergoes both addition reaction and substitution reaction. So the first one is halogenation. And when we say addition reaction, it shows that everything will come in. Under substitution reaction, we displace hydrogen and you will replace with an atom, group of atom or an alkyl group under substitution reaction. But this time around, you add it to it. That is, you are not replacing anything. So the best way to explain this addition reaction is to use an open structure of benzene, which is called Kekule structure. I'm going to use the open structure of benzene to explain this chemical reaction, this addition reaction. So let's use open structure of benzene. So with our 6 carbon atoms, that is hexagonal in shape. Then you add your hydrogen atoms. Then your double bond. Then plus an halogen. You can use any of these halogen. You can use chlorine, you can use bromine. You can use bromine, then you can use what? Iodine. Then don't forget that the halogens are diatomic what? They are diatomic molecules. They are the diatomic gas. Now, for anything to come into this structure, if you look at each carbon atom, the carbon atoms are fully occupied. That is, there is no room for what? For halogens to come in. The only thing you can do for any halogen to come in is to open what? The double bonds. So we have to open the double bond now. For nothing can come in because we are not removing anything for any other thing to come in now. Now, the only thing we can do is to open the double bond for the halogens to come in. So therefore, let me add bromine, which is a diatomic molecule. So our structure now, all the double bonds we open for bromine to come in. Then we have double bond here, double bond here, double bond here. So to remove this first double bond, this bond attached to this carbon atom up and the carbon atom down. So when you remove this double bond, you must attach it to this carbon atom and the carbon atoms. Then this double bond too, this double bond, when you remove this double bond, the double bonds attached to this carbon atom, the third carbon atom and the fourth carbon atom. So when you remove it, you must attach it to this third carbon atom and the fourth carbon atom. Then there's another double bond here. This double bond attached to this carbon atom, the fifth carbon atom and the sixth carbon atom. So when you remove one of these double bond, you must attach it to this carbon atom and this carbon atom. So to this carbon atom. So therefore, we have 6 empty bonds. We have 6 empty bonds. So 1, 2, 3, 4, 5, 6. So we need 6 bromine to fill those what? Those 6 chemical bonds. So we need 6 chlorine, and we have 2 chlorine here. So we have to multiply these 2 by 3 to give us 6. So I will put 3 here. So 3 times 2 will give us 6. So those 6 bromine can come in. So you attach one bromine here, one bromine here, bromine here, bromine here, one bromine, and the last bromine. So this structure is no more what? It's no more a structure of benzene, because benzene has what? Double bond in its structure. Then this is a single bond. This is a single carbon bond, or single chemical bond. So when you have single bond with a closed chain, so we call it a cycloalkane. This is a cycloalkane. So what will you call it now? An alkane with 6 carbon atoms. 1, 2, 3, 4, 5, 6. An alkane with 6 carbon atoms is what? Is known as hexane. So this is the structure is cyclohexane. We call it cyclo because the chain is being closed. It's not a straight chain hydrocarbon. It's not a straight chain hydrocarbon. That is why we call this what? A cyclo. So we call this structure cyclohexane. Then at the same time, you have to name the position of all these bromine. So let's name this structure now. So this structure is called, now this is the first carbon atom here. This is the second carbon atom, 3, 4, 5, 6. So the first bromine is on the first carbon atom. So we call it 1, comma. Then the second bromine on the second carbon atom, comma 2. Then another bromine on the third, 3. Then another one on the fourth carbon atom, 4. another one on the fifth carbon atom 5, another one on the sixth carbon atom 6. Then how many bromine altogether? That is 6 bromine. 6 is called hexa in chemistry. So that will be hexabromo, hexabromo, hexabromo. Then hexabromo what? This close chain is called cyclo. Then cyclo what? Hexane, because we have 6 carbon atoms. So the structure is called 1, 2, 3, 4, 5, 6 hexabromo, then cyclohexane. 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 Then if you replace bromine with chlorine, so you are still going to name it. We are still going to name it the same way we named this bromine. If you replace all this bromine, and if there's an attachment of bromine molecule here, you replace all this bromine with chlorine. So if you call this 1, 2, 3, 4, 5, 6, that one will now be hexachlorocyclohexane. Hexachlorocyclohexane. Then the last chemical reaction under this addition reaction is called hydrogenation. Hydrogenation, number 2. Hydrogenation. So hydrogenation means addition of hydrogen. Hydrogenation means addition of hydrogen. That is, you add hydrogen to your benzene molecule. Addition of hydrogen to benzene molecule. Then, and I told you that the best method to use is what? The open structure of what? Of benzene. So we are going to use the open structure of benzene to explain this structure. Then halogenation, that is addition of hydrogenation, means addition of hydrogen. So that hydrogen is a diatomic gas. Then now for hydrogen to come in, you have to open all these double bonds because you are adding hydrogen to the structure. So let's open the double bond. So we have double bond here. There is double bond there. There is double bond there. So when you open this double bond, you attach to the carbon atom up and the carbon atom down. So you attach it to this carbon atom and this carbon atom. Then when you open this double bond, you attach it to this carbon atom and the carbon atom down. When you open this one, the one of the bond attached to the carbon atom up and the carbon atom down. So by the time you open it, you attach it to this carbon atom and the carbon atom. So we have 6 empty bonds. We have 6 empty bonds. So we need 6 hydrogen to fill those chemical bonds. So we have to multiply this hydrogen, 2 hydrogen by 2. 3 times 2 will give us 6. Then you put 1 here. 1, 2, 3, 4, 5, 6. Now from this structure now, there is no substituent. There is no substituent because carbon and hydrogen are not substituents in organic chemistry. Carbon and hydrogen are not what? Substituents in organic chemistry. Then the structure is no more a structure of benzene. It is no more a structure of benzene. So therefore, since we have a single bond in between carbon atoms, so it belongs to an alkane. Then the chain is being closed. It shows that it is a closed chain alkane. It is a closed chain alkane. So what are we going to, what do we call a closed chain alkane? We call it cyclo. So cyclo what? So we are an alkane with 6 carbon atoms is called hexane. So therefore we call it cyclohexane. 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 So the name of this structure is cyclohexane. Cyclohexane. So we have come to the end of today's class. Remember to subscribe to Royal Learning Channel to learn more about chemistry, and I'm very sure that you will never regret it. Join Royal Learning Channel for your chemistry class. See you in my next video. Bye.